Good morning. This is your stats sensei, Mr. Spensei, and this is the warm. This is not the warm up. This is the our test review, and we've previously did the hypothesis test. Now we're going to do a confidence interval for our test review. Still working with the same scenario, but I'm going to go over it again. So defective autos. When a law firm represents a group of people in a class action lawsuit and wins that lawsuit, the firm receives a percentage of the group's money. That settlement amount is based on the total number of people in the group. The larger the group and the larger the settlement, the more money the firm will make. A law firm is trying to decide whether to represent more than 100,000 car owners. That's probably the population. That's a big number. That sounds like the big group is 100,000 in a class action lawsuit against the manufacturer of a certain make and model for the particular defect. If 5% or less of the cars of this make and model have the defect, the firm will not recover its expenses. Therefore, the firm will handle the lawsuit only if it's convinced that more than 5% of the cars have this defect. We've already done the hypothesis test, so we're going to look at scenario 2. And it says a random sample of 637. All right, so we know we have a random sample. We have a sample size of 637 out of that whole population of 100,000. We're asked if they experienced this defect in their cars and found that 53 people had experienced this defect. So it sounds like we have a sample size of 637. Of that, we have the group of interest is 53 have the defect. And it says create a 99% confidence interval for the proportion of defects that this vehicle has. All right, so the proportion of defects, and this got cut off, that this vehicle has. So let's take a look at this and let's go ahead and run this thing. So the very first thing is, well, what is our parameter? Well, our parameter is the proportion of vehicles that have this defect. So let P equal the true population proportion of cars with this defect. We don't know what the defect is. Maybe the brakes don't work. I don't know. So our formula, P hat plus or minus Z star P hat times 1 minus P hat over N. This is just our formula. It's on your recipe sheet. All right. List and label our important information. Well, we know our sample size is 637. We know our X is 53. So we can get P hat now, because P hat is just X over N. So 53 over 637. And in this case, 53 divided by 637, we get 0.0832. And the next thing is it asks for our confidence level. And they say, oh, we want a 99%. So our C level is 0.99. So the conditions, all right. Well, our first condition, that's the one everyone does great on, random sample. They almost always tell us it is. Random sample of 637. That was given. That was so nice. We can check it off. That's good. The next thing, we need to check that the sample size is less than 10%, so we can sample without replacement. So in this case, we have N equals 637. And most everyone is doing this very well now. They're telling me, hey, we need to multiply by that 10. They get 6,370. And we need to compare that. We need to make the comparison to our population. Well, sure enough, that's less than the population, so we're good to go. So less than 100,000. We'd have to use different techniques that are beyond this course if it was greater than that. All right, the next one. So when we were doing the hypothesis test, normality was based on NP. We don't know what P is on the confidence interval. We're using P hat because we're trying to estimate NP. So we have to use NP hat. So make sure that this one's NP hat. The hypothesis test is NP. So in this case, it's the sample size of 637 times 0.0832. And when we do that, we're going to find out that it's approximately 53, and that's greater than 10. So the first part's good. Then we need to do n times 1 minus p hat, because I have to satisfy both of these, not just one. 637 times 1 minus 0.0832. So 637 parenthesis 1 minus 0.0832. Close those parentheses. And we get 584. And that's also greater than 10. So it's normal enough to use the approximation. It's close enough to use the normal approximation, or large enough to use it. So we need to calculate Z star. So this is going to be an inverse norm. And it's going to ask for our area. And our area is going to be 1 minus 0.99 divided by 2. And we're always going to go left if your calculator has that. So here we go. Second vars, inverse norm, 1 minus, clear that out, 1 minus 0.99 divided by 2. Oh, we're doing a z-score. All z-scores have a mean of 0 and a standard deviation of 1. We want a left tail. And so we have the, and we're positive people, so we're going to take this negative and make it a positive. So our z-score equals 2.5758. All right, now that we have that information, we can plug all this into our formula. So p hat 0.0832, 0.0832 plus or minus our z star, which we just found of 2.5758 times our next thing. We need to plug this in. So we have 2.5758. Oops, excuse me. 0.0832 in the numerator, and then 1 minus 0.0832 over my sample size, and my sample size happens to be 637. All right, letting the calculator do her work. Stat, arrow over to test, drop down to number 5, which is 1 proportion z-test. Oops, we're not doing a z-test, we're doing a z-interval. So stat, test, we're going to drop all the way down to letter A, so 1 proportion z-interval. And our sample size, we said was, our group of interest was 53. Our sample size was 637. And our confidence level is 0.99. And we end up getting an interval of 0.055, so 0.0550 to 0.111, 1113. I'll rewrite that. 0.0550. Sorry for the mistakes, guys, but I guess it's a little bit early for me this morning. 0.1113. All right. So the interesting thing is this is greater than 5%. 5% is not in this. This is above 5%. So that based on our confidence interval, we're going to say, hey, as opposed to the hypothesis test, they're going to say, hey, we need to go sue this car company. We're going to make money. So in this case, they'd probably take this case. So our conclusion, well, what are we? Well, we are 99% confident that Well, what are we confident of? The true population proportion of cars that have the defect. What are we confident about? That it lies within the interval 0.05502 to 0.1113. And then finally, what is the meaning of our confidence level? In repeated sampling, we are so confident. Our method is so awesome. We expect this method or our method to capture, what's it capturing? The true population proportion of cars that have the defect. Capture the true population this defect. How often? We expect to capture it 99% of the time. If we'd use a 96% confidence interval, we would expect to capture it 96% of the time. So 99% of the time. All right, guys, I appreciate you watching. I hope this helped. Study for your tests, and we will see you on the next one.